Good morning. Today we have to start one more topic, 12th, about electromagnetic induction. Electromagnetic induction. Today we have to start one more topic about electromagnetic induction. Now see, the phenomenon in which an EMF induces in a circuit. The phenomenon in which an EMF induces in a circuit when there is change in magnetic flux across it. The phenomenon in which an EMF induces in circuit when there is change in magnetic flux linked across it is called as electromagnetic induction. म्हणजे जर समजा एखाद्या क्लोज्ड सर्किटचं मॅग्नेटिक फ्लक्स चेंज केलं, तर त्यामध्ये EMF इंड्यूस होतो. See here, the phenomenon in which an EMF induced in a circuit due to change in magnetic flux linked across that circuit is called as electromagnetic induction. Now, experimental observations. Of Faraday's laws. Experimental observations of Faraday's laws. First, that is magnet coil experiment. See, an experiment consists of a coil. An experiment consists of a coil. An experiment consists of a coil connected to galvanometer and a bar magnet. Suppose this one as N pole, this one as S pole, like this. See here. Experimental arrangement consists of a coil connected to galvanometer which formed a closed circuit and a magnet. Observations. First, when magnet moves towards coil, then galvanometer shows deflection and EMF induces in circuit and galvanometer shows deflection. Second, इथं काय पाहिलं आपण, when magnet moves towards coil. When magnet moves towards coil, then current flows through circuit and galvanometer shows zero deflection. Second, when magnet moves away from coil, then again galvanometer shows deflection, but in opposite direction. Third one, instead of magnet, if coil moves towards or away from magnet, when coil moves towards or away from magnet, then galvanometer shows deflections in opposite directions. Fourth one, the magnitude of induced EMF. The magnitude of induced EMF depends upon rate of change of magnetic flux. Depends upon, फार त्रास म्हटलं तरी चालेल या ठिकाणी, the magnitude of an induced EMF depends on number one, that is relative speed of magnet and coil, and one more, that is number of turns in coil. And one more observation, induced EMF exists only when there is change in magnetic flux linked with circuit. This is magnet coil experiment. Observations बघा, when magnet moves towards coil, then current flows through coil and galvanometer shows deflection. Second, when magnet moves away from coil, then again galvanometer shows deflection, but in opposite direction. Third one, instead of magnet, if coil moves towards or away from magnet, then again galvanometer shows deflections, but in opposite directions. The magnitude of induced EMF. The magnitude of induced EMF depends upon relative speed or relative motion of magnet and coil and number of turns in coil. One more, induced EMF exists only when there is change in magnetic flux linked with coil. हा जरा आपला पहिला एक्सपेरिमेंट. सेकंड एक्सपेरिमेंट, that is coil experiment. Coil experiment. पहिला आपण पाहिला मॅग्नेट कॉइल एक्सपेरिमेंट. आता आपण पाहतोय कॉइल एक्सपेरिमेंट. Experimental arrangement consists of two coils placed with their planes are parallel to each other. हित एक कॉइल आणि समजा हित एक कॉइल आहे. Experimental arrangement consists of two coils like this. Experimental arrangement consists of two coils placed with their planes parallel with each other. One coil is connected. One coil is connected in series with a cell, plug key and rheostat. Battery E, plug key K, rheostat called as primary coil. And another coil is connected to galvanometer. Called as secondary coil. Experimental arrangement consists of two coils placed with their planes parallel to each other. One coil is connected in series with a cell, plug key and rheostat called as primary coil, and another coil connected to galvanometer is called as secondary coil. Observations. First, when current passed through primary coil. Then galvanometer shows momentary deflection. When circuit is closed or broken. When primary circuit is closed or broken. When primary circuit is closed or broken, then galvanometer shows momentary deflection but in opposite directions. Second one, म्हणजे जर समजा करंट पास केला तर गॅलव्हॅनोमीटर मध्ये डिफ्लेक्शन मिळतं, करंट स्टॉप केला तर गॅलव्हॅनोमीटर मध्ये परत डिफ्लेक्शन मिळतं बट इन अपोजिट डायरेक्शन्स. When primary circuit is closed or broken, then galvanometer shows deflections but in opposite directions. Second one, the magnitude of induced EMF in secondary. Magnitude of induced EMF in secondary depends upon relative speed or relative motion of coils and number of turns in secondary. Depends upon relative motion of coils and one more, that is number of turns in coils. One more. Third observation, whenever current in primary changes, whenever there is change in current in primary, galvanometer shows deflections. Means EMF induces in circuit secondary and galvanometer shows deflection. When direction of current in primary changes, then deflection in coil also changes. These are Faraday's experimental observations of Faraday's laws. electromagnetic induction, the phenomenon in which an EMF induces in circuit when there is change in magnetic flux linked across it. Experimental observations of Faradays laws. आपण दोन एक्सपेरिमेंट केलेत, मॅग्नेट कॉइल, कॉइल एक्सपेरिमेंट. From these observations, Faradays laws. Faradays laws. First, that is qualitative law. Qualitative law, and one more, that is quantitative law. Qualitative law and quantitative law. Qualitative law, whenever there is change in magnetic flux linked with coil, closed circuit पाहतो म्हणा. Whenever there is change in magnetic flux linked with closed circuit and EMF induces in circuit. And quantitative law, the magnitude of induced EMF. The magnitude of induced EMF is directly proportional to rate of change of magnetic flux linked with closed circuit. The magnitude of an induced EMF. The magnitude of an induced EMF is directly proportional to rate of change of magnetic flux linked with circuit. Faraday's laws. There are two laws: qualitative law and quantitative law. Quantitative means quantity of EMF induced. Qualitative means types of or direction of induced EMF, like this. Qualitative law, whenever there is change in magnetic flux linked with closed circuit and EMF induces in circuit. Quantitative law, the magnitude of an induced EMF in closed circuit is directly proportional to the rate of change of magnetic flux in closed circuit. To remove this proportional sign, we have to take constant, that is E is equal to K into d phi by dt. If E, phi, T are measured in same system of unit, then value of K is equal to 1, and therefore E is equal to d phi by dt. Okay. These are Faraday's laws of electromagnetic induction. Now, next one, Lenz's law. L-E-N-Z-S. Lenz's law of electromagnetic induction. Lenz's law of electromagnetic induction. The direction of an induced EMF. The direction of an induced EMF is such that it opposes the change in magnetic flux linked with circuit, that is E is equal to d phi by dt. d phi by dt, that is rate of change of magnetic flux. E, that is EMF induced, but their directions are opposite with each other, therefore we have to take minus sign. This negative sign shows that direction of an induced EMF is opposite to that of rate of change of magnetic flux which produces induced current. आता याच्या आधारे आपण काय पाहतोय, कॉन्झर्वेशन ऑफ लेन्स लॉ, एनर्जी कॉन्झर्वेशन इन लेन्स लॉ. एनर्जी कॉन्झर्वेशन in Lenz's law. Energy conservation in Lenz's law. What is Lenz's law of electromagnetic induction? The direction of an induced EMF. The direction of an induced EMF is opposite to that of rate of change of magnetic flux which produces induced current. आता याचं आपण ऍप्लिकेशन पाहतोय एनर्जी कॉन्झर्वेशन इन लेन्स लॉ. नाउ सी energy conservation in Lenz's law. Suppose this one as a coil like this. Suppose this one as a coil like this. आणि समजा या ठिकाणी हा एखादा मॅग्नेट आहे. नसियर एनर्जी कॉन्झर्वेशन इन लेन्स लॉ 2 पॉइंट आहे. फर्स्ट, when n pole of magnet, when n pole of magnet moves towards coil, moves towards coil, then EMF induces in circuit or EMF induced in circuit which produces magnetic dipole in loop. This dipole is oriented such that face of coil towards magnet acts as n pole. The face of coil facing towards n pole acts as n pole. पर पान काय म्हणतो ते when n pole of magnet moves towards coil, then an EMF induces in coil, due to which coil acts as magnetic dipole with n pole facing towards n pole. N pole facing towards n pole. This dipole is oriented such that it opposes the motion of magnet. परत एकदा बघा. When n pole of magnet moves towards coil, when n pole of magnet moves towards coil, then an EMF induces in circuit किंवा EMF induces in coil. This EMF produce magnetic dipole in loop. This dipole is oriented such that it opposes the change in magnetic. It opposes the motion of magnet. That is, face of coil towards magnet acts as N pole and tries to oppose magnet. Therefore, coil produces anticlockwise current. Coil produces anticlockwise current. बघा परत आहे ना, समजावून घ्यायचंय. When N pole of magnet moves towards coil, when N pole of magnet moves towards coil, then EMF induces in coil, which produces magnetic dipole. This magnetic dipole is oriented such that face of coil facing towards N pole acts as N pole and tries to oppose the motion of magnet, and hence external work has to be done on magnet. External work has to be done on magnet. This work is converted into EMF. This work is converted into EMF and current flows through coil. याच्या बरोबर अपोजिट आता. Second, when N pole of magnet moves away from coil, when N pole of magnet moves away from coil, then again EMF induces in coil, and now coil is oriented such that face of coil towards N pole acts as S pole and tries to attract magnet, and hence external energy is required to move magnet away from coil. This energy is converted into EMF. Thus energy is converted into EMF. External work or energy is converted into EMF. This law follows directly from conservation of energy. Okay, this is about Lenz's law of electromagnetic induction. म्हणजे इथं काय होतं तर आपण जे वर्क करतो तेच वर्क त्यामध्ये EMF च्या स्वरूपामध्ये स्टोर होत असतं. मीन्स एक्सटर्नल वर्क इज कन्वर्टेड इनटू EMF. मीन्स mechanical work is converted into electrical work, or mechanical energy is converted into electrical energy. This follows that Lenz's law is directly applicable from conservation of energy. Okay, this is about Lenz's law. Remaining part on next period.